The broadcast is now starting. All attendees are in listen-only mode.
To the Department of Healthcare Access and Information, or HCAI, fire resistance rated assembly. Protection of penetrations, joint systems, and openings in rated assemblies, protection of different types of assembly types, and much, much more. If you haven't done so already, feel free to download this presentation made available to you in PDF format under the handout section of the GoToWebinar toolbox on your screen. You are here for about an hour and a half presentation, depending on how many questions you have. But if you have any questions during the presentation, feel free to type the question into the question box of the GoTo software toolbox, and we will answer those at the end of the presentation. If you do have a question that's specific, send your question over to the email at regsunit@hci.ca.gov. Again, that's for specific questions for specific projects. Send it over to regsunit@hci.ca.gov. That's regsunit@hcai.ca.gov. If you experience transmission difficulties, please feel free to log off and log back in using the login information that the GoTo software sent you in your email. Today for a presenter, we're going to have Ms. Nanci Timmins. She is the Chief Fire Safety Officer within HCAI, and she's going to be doing the presentation today. So once again, thank you for joining us, Nanci. So if you're there, I hand the presentation over to you.
Thank you very much, Caesar. And hello again, everybody. Thanks for joining again today, and welcome to this second portion. If you, either way, if you joined last time or not, so we're going to build upon, no pun intended, where we left off. So as Caesar mentioned, we talked about the fire resistive rated assemblies, what to name the walls, what are they. If you recall, Chapter 7 indicates how to build them, but other sections of the code will tell you where. And also in 7, as Caesar mentioned, are the how to protect the joints, so penetrations, joints, assemblies, the opening protectives, how all this needs to take place so that that fire resistive rated assembly is continuous with all parts needed. So we have a lot of information today. Again, just like the first time, we had a lot of information, a lot of slides to go through. So we will hold questions till the end, and there will be another presentation because we will get into, or we should, timing wise, get into the opening protectives, but we will not get through all of it. If you've taken a look at that section, it's pretty lengthy. So we won't get through all of it, but we will hopefully get to a portion of it, and then we'll pick up again on the third presentation. So again, thank you very much for joining, and I'll apologize beforehand. There's a lot of code in this one, so I will be reading a lot of code. I know that's not an exciting way to present, but when teaching the code, that kind of just comes with that. So it's good information, but there's a lot of code in there. But different from the version that you have for your handout, there are also a lot of pictures to make it better. So hopefully you're able to view the presentation as well, in addition to having the handout in front of you. All right, so we're still in Chapter 7. And the first that we'll start talking about are the penetrations, which those are in section 714. And as always, you start with the whole scope for that specific chapter and then each specific section. So 714.1 indicates that the provisions of this section shall govern the materials and methods of construction used to protect through penetrations and membrane penetrations of horizontal assemblies and fire resistance rated wall assembly. So the scope, of course, is talking about through and membrane penetrations. And then, so when you're reading through the code, make sure that you're looking at the right one. Are you looking at through? Are you looking at membrane? Or do you have to look at a combination because of your type of penetration. And then also, where is it? Is it in the horizontal assembly, the floor ceiling, roof ceiling assembly, or the rated walls? For ducts and air transfer openings, that indicates that the penetrations of the rated walls by the ducts that are not protected with dampers have to comply with section 714.3 through 14.4.3. And then penetrations of horizontal assemblies not protected with a shaft as permitted by section 717.6. We'll get to that next time. But there are some, and you're not really going to see that in I2, but if they don't need a shaft for some reason, then there's other ways that have to be protected. And they don't need dampers. If they don't need the shaft or the dampers, then they have to comply with 714.5 through 14.6.2. Again, you don't see that too much for the I2. Ducts and air transfer openings that are protected with dampers shall comply with 717. So this section just basically leads you to the other sections that are applicable for when you're talking about ducts. So for where you're more often going to go is to 717 because they're going to be protected with dampers and then shafts. So the note here that duct penetrations must be protected when dampers are not provided, and that can occur when ducts are part of a smoke control system, for example, right? You wouldn't want to put a damper inside a smoke control system, duct, the mechanical smoke control system like your atrium, your stair pressurization. It doesn't really help with the smoke there. So installation, a listed penetration fire stop system shall be installed in accordance with the manufacturer's installation instructions and the listing criteria. So we always wonder, where does it talk about manufacturer installation requirements? Right here, 714.2. So not only does the listing for the penetration, the installation for the penetration have to comply with how it's been listed and tested, but also in accordance with the manufacturer's installation and instructions. So always remember to look at both the listing and the instructions. When looking at the details where sleeves are used, they shall be securely fastened to the assembly that they penetrated. You can see an example of that on the picture on the left. The space between the item contained in the sleeve. So like on the left, and the picture above, you've got the sleeve and then the items inside of it. So that space in between, and any space between the sleeve and the assembly that is penetrated, the wall, the horizontal assembly, etc., shall be protected in accordance with this section, 714.3. Insulation and coverings on or in the penetrating item shall not penetrate the assembly unless the specific material used has been tested as part of the assembly in accordance with this section. So just like anything that we're looking at, if it's part of an assembly is not just one thing, it's a bunch of things put together that were put through a test and then are assembled together, right? So what is being installed in here has to match how it was tested and then how it's listed. So again, protecting the space in where the item is going through the sleeve, because doesn't really do you much good if you got a hole going through there where the cables are going. But we see that all the time. Just the other day I was showing a picture to staff of where it was just one, but still the way smoke travels, especially in the pressure of a fire, it doesn't take much to spread that smoke. I should have added that slide in here. I've got a slide of that shows a small room. It shows the calcs for how long it takes a small room to fill with smoke with a dime size hole in the wall. And I don't remember the dimensions of the room. I think it's like 16 by 16 or something. It's really small, and it takes like 2-3 minutes, but it fills up pretty quick. But anyway, that's why this is all important. So if this is talking about filling an interior, the inside of that sleeve, as well as where the sleeve is penetrating the assembly, the wall or the floor. So switching to 14.4 for fire resistance rated walls, penetrations into or through fire walls, fire barrier walls, smoke barrier walls, and fire partitions shall comply with section 714.4.1 through 4.3. Penetrations in smoke barrier walls shall also comply with 714.5.4. So for a smoke barrier wall, there's a bit more. So for all the walls, they're complying with 14.4.1 through 4.3, smoke barriers at 7.14.5.4. And then, so what are those sections? So 7.14.4.1 starts off with the through penetrations and indicates that those have to be protected in accordance with 7.14.4.1.1 or 7.14.4.1.2. And then there's an exception to this where the penetrating items are steel, ferrous, or copper pipes, tubes, or conduits. The annular space between the penetrating item and the fire resistance rated wall is permitted to be protected by either of the following measures. So again, the exceptions for just these types of materials, and they can be protected by either of these. So I put a little hint on top of each of these of which one you would use for what. So for number one, you could use that for ferrous metal pipe and conduit penetration. So number one says in concrete, oops, there's extra spaces there. In concrete or masonry walls where the penetrating item is a maximum 6-inch nominal diameter and the area of the opening through the wall does not exceed 144 square inches. So both criteria to be met. Well, three, right? The type of item. And then maximum 6-inch nominal diameter and then 144 square inches max. Then concrete, grout, or mortar is permitted where it is installed the full thickness of the wall or the thickness required to maintain the fire resistance rating. Or number two, which you would use for metallic pipe and conduit penetrations, the material used to fill the annular space shall prevent the passage of flame and hot gases sufficient to ignite cotton waste when subjected to ASTME 119 or UL 263, time temperature fire conditions under a minimum positive pressure differential of 0.01 inch of water at the location of the penetration for the time period equivalent to the fire resistance rating of the construction penetrated. So the temperature needed to ignite the cotton waste is 410 degrees, but that's not the point. If you don't want to use a fire stop system tested in accordance with ASTME 814 or UL 1479, it's going to take a lot of time, work, and money to test it for ASTME 119 or UL 263. You might remember from the previous presentation, these ASTME 119 or UL 263, that's the testing standard that your assemblies have to be tested to. So the section is saying, okay, well, if you don't test it with the fire stopping type, the standards, the ASTME 814 or UL 1479, then it's going to have to be tested as part of the test that the assembly went through with those same materials in ASTME 119 or UL 263. There are enough listed systems out there where you should be able to just find the one that's tested for the fire stop. So just some examples that match those exception number one and number two to help you visualize that a little bit more, what they're talking about. And then moving on to 7.14.4.1, for fire rated assemblies, through penetration shall be protected using systems installed and tested in the approved fire resistance rated assembly. So the section requires that as an option, the tested assembly in accordance with ASTME 119 UL 263, again, the testing standards that's for your fire resistive rated assembly, that these include the penetrations, kind of what we just talked about, include the penetrations along with the proposed type of protection. So the whole thing is tested together. And as an option, the section is not used frequently due to the limitations placed on the tested assembly relative to its application, because you got to test it exactly as it's being installed. So imagine the number of tests that would be that would include. So again, there are so many tested systems out there that you're not going to see this one too much. That would take a lot to go through this one, but find the listed approved assembly. The sites like UL and Intertech are really, really, really improved in the past year or two, where you can go look on there, and there are a bunch of search criteria that help you. I mentioned this last time, but I'll keep on mentioning it because it's the design professional's responsibility to find if a listed system exists, and if it does, it's required to be used. So how do you find those? You don't have to go through the volumes of hard copy UL anymore. You can go to the UL site and look at plug in what you have. Are you looking at a horizontal floor ceiling assembly? Is it a 1 hour fire barrier? What are you looking at? It lets you put in all that criteria, and what are you using? It's what type of construction are you looking at? Even that you can put that in there, and it'll generate a list of a bunch of the listed systems that are similar to what you're saying you're looking for, and then you go through that list and find the one that matches your condition. Their sites make it a lot easier. The change was made probably, they always had search criteria, but they've really improved on that with probably in the last, I keep saying year, it's probably been like 2 years now. So again, still with the through penetrations shall be protected by an approved penetration fire stop system installed as tested in accordance with ASTME 814 or UL 1479 with a minimum positive pressure differential of 0.01 inch of water, and shall have a F rating of not less than the required fire resistance rating of the wall penetrated. So yes, of course, we expect this. The T rating isn't required for through penetrations in walls. For membrane penetration, so remember it said, you're complying with this or this. So now we're at the 714.42, and this is talking about membrane penetrations. You're only going through one side of your fire resistive rated assembly as opposed to going through the whole thing. So membrane penetration shall comply with 714.41. So you do have to go back and follow those. And then where walls or partitions are required to have a fire resistance rating, recessed fixtures shall be installed such that the required fire resistance rating will not be reduced. I don't know why I said that. Will not be reduced. So of course, there are exceptions, but again, putting some visuals with it to kind of make it a little bit better. The exception to that charging section is membrane penetrations of maximum 2 hour fire resistance rated walls and partitions by steel electrical boxes that do not exceed 16 square inches in area, provided the aggregate area of the openings through the membrane does not exceed 100 square inches in any 100 square feet of wall area. The annular space between the wall membranes and the box shall not exceed 1/8 of an inch. Such boxes on opposite sides of the wall or partition shall be separated by one of the following. So again, your charging section indicates that the recessed fixtures have to be installed, obviously, so that the fire resistance rating is not reduced. And then, how, this is more of a how than an exception, but how would you do it if you had a steel electrical box? This gives you the parameters for steel electrical boxes. And they're not, anyway, it's easier just to read this. So steel boxes, and then it says by one of these. So sorry to go back and forth like that. If they're on the opposite side of the wall, then you have to separate them by one of these, either by a horizontal distance of not less than 24 inches, where the wall or partition is constructed with individual non-communicating stud cavities, like no punch studs or ladder studs, or 1.2 by a horizontal distance of not less than the depth of the wall cavity, where the wall cavity is filled with cellulose loose fill rock wool or slang with mineral wool insulation, or 3 by solid fire blocking in accordance with 718.21, 4 by protecting both outlet boxes with listed putty pads, or by other listed materials and methods. So different options of what to do when there are the boxes on the opposite side of the wall, which is very common. So limitations and allowances in this section. And yeah, another piece is where you talk about the annular space between the firewall membrane and the box that shall not exceed 1/8 of an inch. That sometimes is forgotten. It's right there in 714.42, exception 1 and 2. You get that one. Where does it say 1/8 of an inch? It's in that section. Continuing on with the exceptions, the membrane penetration by listed electrical boxes of any material provided such boxes have been tested for use in fire-resisted rated assemblies and are installed in accordance with the instructions included in the listing. The annular space between the wall membrane and the box shall not exceed 1/8 of an inch unless listed otherwise. Such boxes on opposite sides of the wall or partition shall be separated as follows. So I'm going to back up again, sorry, back and forth. So this one, we're talking about the steel electrical boxes. So exception number 1 is for steel electrical boxes that don't exceed those sizes. Exception number 2 is talking about the electrical boxes of any material and what you can do there. So if you've made it through the first part, qualifies there, then you go on to the following. How do you protect them when they're on the opposite sides of the wall? For 2.1, by the horizontal distance specified in the listing of the electrical boxes. 2.2, by the solid fire blocking in accordance with 718.2.1. 3 is by protecting both boxes with listed putty pads, or 4, by other listed materials and methods. So again, this one's the exception for the listed plastic boxes. And regardless of how, if it's listed, the separation requirements still apply. And then it's the visual of that one. But, and then so, and just to give you these are required, the fire resistance rated non-metallic boxes, they are required to be marked. And then you'll have that UL in the circle, and then the hourly rating. You can see that here too. We have the hourly rating, and then an FW or C for the floor, wall, or ceiling. So when you're looking at those, seeing if they're listed, here's obviously you're going to have the product data, and you're going to have the listing, but here's obviously another way where you verify that. Again, then exception number 3, membrane penetrations by electrical boxes of any size or any type, which have been listed as part of a wall opening protective material system for use in fire-resistant rated assemblies, and are installed in accordance with the instructions, including the listing. So these types require the testing in the wall assembly, again, in accordance with ASTME 119 or UL 263. So these are tested. They're in that furnace with that wall assembly. They're not in the furnace by themselves, like with the other standards. And then exception 4, the membrane penetrations by boxes other than electrical boxes, provided such penetrating items and the annular space between the wall membrane and the box are protected by an approved membrane penetration fire stop system installed as tested in accordance with ASTME 814 or UL 1479, with a minimum positive pressure differential of 0.01 inch of water, and shall have an F&T rating of not less than the required fire resistance rating of the wall penetrated, and be installed in accordance with this listing, of course. In these cases, the T rating is required because these penetrations may be greater than 16 square inches. It doesn't have the limitations like the exception 1 did. Where would you see, like, what's an example of number 4? Like a med gas panel is one example, not the only example, but that would fit, a med gas panel would fit here with this exception. And these are just some examples of the fixtures for recessed installation and fire rated construction list by Warnock and Hersey. So just some visuals for you there. Now, and another exception, number 5, the annular space created by the penetration of an automatic sprinkler, provided it's covered by a metal escutcheon plate. So that opening there is going to be protected with that escutcheon. And then 6, lots of exceptions. So number 6 is for membrane penetrations of maximum 2-hour fire resistance rated walls and partitions by steel electrical boxes that exceed the 16 square inches in area, or steel electrical boxes of any size having an aggregate area through the membrane exceeding 100 square inches and any 100 square feet of wall area, provided such penetrating items are protected by listed putty pads or other listed materials and methods, and installed in accordance with the listing. So it must be listed, and this exception is only for the electrical boxes. Then when you have dissimilar materials, non-combustible penetrating items shall not connect to combustible items beyond the point of fire stopping unless it can be demonstrated that the fire resistance integrity of the wall is maintained. So you can see an example here on the picture above. You've got the transition from combustible to non-combustible, and that's not permitted unless it's confirmed via the testing that it can be there, like beyond that fire stopping. For horizontal assemblies, so if we switched 714.5, now we're talking about the horizontal assemblies, floor ceiling, roof ceiling, etc. Penetrations of a fire resistance rated floor, roof ceiling assembly, or the ceiling membranes of a roof ceiling assembly, not required to be enclosed in a shaft by 712.1, shall be protected in accordance with 714.5.1 through 714.5.4. So again, talking about the floor ceiling assembly or ceiling membrane of a roof ceiling assembly. That doesn't have to be in a shaft. So the ceiling portion, because again, it's not just one thing, right? The ceiling might have a rating, but by itself, it is not a complete horizontal assembly. It's the ceiling portion and the roof portion that make the entire assembly. So if you've got something that's just going through the ceiling portion, and it does not need to be in a shaft, then it still needs to be protected. How so? You go look at 714.5.1 through 5.4. So when that's a through penetration, the through penetrations of horizontal assembly shall comply with 714.5.1.1 through 5.1.2. The picture is just the example, just a visual showing you a horizontal assembly and then the system that it has. You can see that this has an FT and L rating. The L is the leakage rating that's required for smoke barriers, and even though a smoke barrier is a smoke barrier wall, a smoke compartment consists of the walls and the floor ceiling assembly above and below. So it's the whole cube. So that's part of that, also needs an L rating. Oh, we talked about that before. We'll talk about it again. So exceptions for this one is again for the type of material, penetrations by steel, ferrous, or copper conduits, pipes, tubes, or vents, or concrete or masonry items through a single fire resistance rated floor assembly, where the annular space is protected with materials that prevent the passage of flame and hot gases. It won't go through all that. You don't need to hear all that. Although it makes it easier to read, I guess, if I read all of it. Sorry about that. I just read it, I suppose, because I got stuck there. So again, penetrations by steel, ferrous, or copper conduits, pipes, tubes, or vents, or concrete or masonry items through a single fire resistance rated floor, just the one floor assembly, and then where the annual space is protected with the materials that prevent the passage of flame and hot gases sufficient to ignite cotton waste. When subjected to ASTME 119, UL 263, by now you should recognize when you hear that, they're talking about the assembly, ASTME 119. When it's the time temperature fire conditions under a minimum positive pressure differential of 0.01 inch of water at the location of the penetration for the time period equivalent to the fire resistance rating of the construction penetrated. Penetrating items with a maximum 6-inch nominal diameter shall not be limited to the penetration of a single fire resistance rated floor assembly, provided the aggregate area of the opening through the assembly doesn't exceed the 144 square inches in any 100 square feet of floor area. You can see some of that similar language. So if you're wondering what is ferrous, it's a description indicating the presence of iron in metal, and it includes steel and pig iron and alloys, and not aluminum. And then exception number 2. I'm not going to read all that through. Just read it. If you got a horizontal assembly and you've got these types of materials, and then with the maximum diameter, just make sure you're in the right exception for the material that you have and the size of that opening. Just make sure you're in the right one. And then, of course, another one for the electrical boxes in the horizontal assemblies. And then those boxes, you make sure that those are tested properly, right? If you've got a electrical box that's tested for fire resistance rated wall assembly, can you automatically use it in the floor? Was it tested that way? So make sure you're looking at that as well. And again, this is the section for the horizontal assemblies. So this is talking about when those are in the floor, make sure it's tested for that. And of course, the installation has to be protected in the way that it was tested and approved in the assembly. And again, this is similar to the one for the wall. If it's through the horizontal assembly and they don't have its own, it doesn't have its own listing, the penetrating item and how it's protected doesn't have its own listing for that individual item, but it can be tested as part, it was tested as part of the whole floor ceiling assembly, then they can use that. But again, we shouldn't really see this too much anymore because there's a number of listings that are available now. And then similarly, the through penetration shall be protected by an approved through penetration fire stop system installed and tested in accordance with ASTM E814 or UL 1479 with the minimum positive pressure differential of 0.01 inch water. And then the system shall have an FT&T rating of not less than 1 hour, but not less than the required rating of the floor penetrated. And again, remember that it's in the hospitals, the floors are also the part of the smoke compartment, so an L rating as well. But this is code for everybody, so it's not always apparent. This is why some people forget that. And then exceptions for this, the floor penetrations contained and located within the cavity of the wall don't require the T rating. They'll still need the F and the L. But if they're in the cavity of the wall, they won't need that T rating. And then for floor penetrations by floor drains, tub drains, or shower drains contained and located within the concealed space of a horizontal assembly do not require a T rating. Yes, they did not list toilet, but you can assume, yeah, it's probably going to work the same, right? And on our site, we have pre-approved details on our OSHPD HCAI site for the fire pre-approved details. You'll see one in there for when you have a penetration from the toilet. Exception number 3, floor penetrations of maximum 4-inch nominal diameter metal conduit or tubing penetrating directly into metal enclosed electrical power switchgear. Those don't require the T rating either. And then penetrations that are part of a fire resistance rated horizontal assembly shall comply with 714.511 or 512. So we're back now to the membrane. So we talked about the through. Now we're talking about membranes through the horizontal assembly. Where floor ceiling assemblies are required to have a minimum 1 hour fire resistance rating, recessed fixtures shall be installed such that the required fire resistance will not be reduced. So we see that a lot in your place, see it a lot of places. But example, if you're 5As and you've got a ceiling roof assembly and that ceiling portion is rated, but again, like I mentioned earlier, it's not the whole assembly, right? That's just one portion of the assembly. The rest of it includes the roof portion, but you've got light fixtures popping up in between, up in that ceiling assembly. Those have to be protected. Yes, you got to maintain that rating. So they're protected or they're listed and tested as part of this assembly. So exceptions to this membrane, again, I don't read all those to you. It's very similar language. So what's the type of material that's going through that membrane? What is the type of it? What's the size? And how does that have to be protected? It's a lot of the same similar language that you see through the others. It's just that it's for horizontal. And the exception 3 and 4, 3 is talking about the electrical boxes of any size or type. And then the number 4 is about the listed electrical boxes as well. So just make sure you're reading the right exception for the material that you have. And then the exceptions again for the sprinkler and the annular space created by that penetration of the sprinkler is going to be covered by an escutcheon. And then if you've got a non-combustible item, that are cast into the concrete building elements. Remember from the first time around, what are your building elements? Those are the items you see in table 601. So if that's in a non-combustible item, that's a huge, make sure it's non-combustible. If it's cast into concrete building elements and don't penetrate both top and bottom surfaces of the element, it's saying that doesn't have to be protected that way. And then exception 7, the sealing membrane of 1 and 2 hour fire resistance rated horizontal assemblies is permitted to be interrupted with the double wood top plate of a fire resistance rated wall assembly that is sheathed with type X chip, provided, so you can do that only if, right? So provided, always big in the code, provided that all penetrating items through the double top plates are protected in accordance with 715.511 or 512, and the sealing membrane is tight to the top plates. You got at least 3 criteria in there to pay attention to. If you're going to use this exception, you got to meet all those. So again, you see it a lot, of course, in the 5A. So it can go through there, but there are some limitations and to that. And then 8, sealing membrane penetrations by listed luminaires, so light fixtures, or by luminaires protected with listed materials. So either, like I mentioned earlier, either that fixture's listed and tested, or how it's the penetration around it is listed and protected. It's giving you the 2 choices here, which have been tested for use in fire resistance rated assemblies and are installed in accordance with the instructions included in the listing. And again, for dissimilar, if you've got non-combustible connecting to a combustible, that can't happen beyond the point of the fire stopping unless it can be demonstrated that the fire resistance integrity of the horizontal assembly is maintained. And then for the smoke barriers, this is the section that says when you have a penetration to the smoke barrier, you need an L rating, and what the test shall not exceed. So you're going to show the listing that includes the L rating in addition to the F and T if T is needed. And which one does it meet? It's going to either meet the 5.0 CFM per square foot of penetration opening for each through penetration fire stop system, or a total cumulative leakage of 50 CFM for any 100 square feet of wall area or floor area. Generally, we're looking at, we could see both, of course, but we typically see the one that complies with number 1. Just please don't forget that it's not, I 3 times, right? I think they say you have to say it 7 times. Don't forget that this includes the floor sealing assembly, roof sealing assembly when it's part of the smoke compartment, not just the wall. When you have non-fire resistance rated assemblies, I'm going to spend a lot of time here because most of the time we are going to have those. But there are some, what has to happen if you do have a situation like that. You can read through that if you ever do, but for the most part with the I2s, they're going to be listed as, rated assemblies. So I'll move on to joint systems. So that was a section for the penetrations. Now moving on to joints and what are they? So there's a visual here on the right, the different kinds of joints that you have. So what are we talking about? First of all, you got the joint at the top of the wall. You can have seismic or expansion joints. The fire resistance rated wall assembly at the side or your exterior wall, for example, you're going to have the joint there at your exterior wall, or rated wall to rated floor, wind joints. So you got all these different joints. So this section is all right. If these joints are at rated assemblies, how do you continue that protection so you don't have little chimneys throughout your building? So the general section for this, joints installed in or between fire resistance rated walls, floor or floor ceiling assemblies, and roof or roof ceiling assemblies shall be protected by an approved fire resistant joint system designed to resist the passage of fire for a time period not less than the required fire resistance rating of the wall, floor, or roof in or between which it is installed. And then fire resistant joint systems shall be tested in accordance with 715.3. Again, remember that these also are, when they're at the horizontal portion, they're still part of that smoke compartment, and you still are looking at an L rating. So a lot of times you will need an engineering judgment to get that L rating in some of these. Some of them, some actually exist. So exceptions to this: fire resistant joint systems shall not be required for joints in all of the following locations: floors within a single dwelling unit, floors where the joint is protected by a shaft enclosure in accordance with 713, and then floors within atriums where the space adjacent to the atrium is included in the volume of the atrium for the smoke control purposes. So if you don't protect it, the joints in between the atrium and the adjacent spaces, those adjacent spaces have to be a part of the smoke control calcs and analysis and all of that. And then floors within malls, and floors and ramps within parking garages or structures constructed in accordance with 4065 and 66. Those are the sections that are specific for parking structures and will have specific requirements for how those are to be constructed and protected. And then, of course, mezzanine floors, and then walls that are permitted to have unprotected openings. That makes sense, right? Roofs where openings are permitted, and then control joints not exceeding a maximum width of 0.625 inch and tested in accordance with ASTME 119 or UL 263. So again, those you'll see the control joints is, so those won't have to be protected as long as the maximum width is shown, the 0.65, and it was tested as part of that assembly that it's in. So both criteria have to be there, not just the size. And then the intersection of exterior curtain wall assemblies and the roof slab or roof deck, which would be able to qualify there unless the roof had to be rated for another reason. And then, just a visual to break it up a little bit. So a lot of these slides are not in. See, if you're following along with your own slides, you have the code language, but you don't have you don't have the visuals, and you don't have some of these notes. These next few slides, I'm just read them to you. They're more like notes, but anyways, this is just UL information about joints and their testing if you're interested. So the hourly fire resistance ratings of the floor and wall assemblies in which or between which the joint system is intended to be installed are covered under the UL fire resistance rating and BXUV, where the individual joint system references back to the fire resistance designs. All construction details of the individual design are intended to be followed. In addition, all details relative to the construction of the wall or floor assembly contained in the individual joint system are intended to be followed. Where the construction details shown in the fire resistance design and the joint system differ, such as in a stud size and spacing, fastener spacing, etc., then the most restrictive construction details prevail, of course. And then for floor to floor and floor to wall joint systems that specify installation in concrete floors, they may include installation of floors consisting of fluted or corrugated steel deck topped with structural concrete, provided that number one, the concrete topping thickness measured above the top plane of the steel deck is equal to or greater than the minimum concrete thickness specified in the joint system. And then two, the joint system does not require any portion of the forming material or fill material to extend below the bottom plane of the floor. And then the basic standard used to investigate the products in this category is ANSI or UL 2079, which is the test for fire resistance of building joint systems, of course. And then ANSI UL 2079, it defines 4 types of joint systems: the floor to floor, wall to wall, and head of wall. And then in addition, the bottom of wall joint systems have been investigated using the general methods and conditions of acceptance specified for the 4 defined types of joint systems. And then all joint systems covered under this category have been investigated with a minimum positive furnace pressure differential of 0.01 inch of water, as you've heard multiple times, maintained at a distance of 12 inches below the horizontal test assemblies and at a mid-height of vertical test assemblies. And then ANSI UL 2079 requires that the joint systems with movement capabilities, your dynamic systems, that they're to be cycled through the intended range of movement prior to the fire test. And then the movement cycling is intended to demonstrate the compatibility between the individual components of the joint system and the fire resistive assembly. Joint systems are required to be cycled through the intended movement range 500 or 100 complete movement cycles at a minimum rate of 1, 10, or 30 cycles per minute prior to the fire test. So that assembly got to be moving before the test, and then they do the test to see how well is that joint system staying in place and doing what it's supposed to do for fire life safety. So yes, we work with structural. What's the movement required for the building structurally, and then do the listed assemblies match what that movement is. We some of the high rises, for example, you might have more movement at the upper levels that's needed structurally. So watch when you have these joint systems, will your joint systems do their listings match? Do they match that movement that's needed? Otherwise, right, they don't. You have an earthquake and they're gonna, or wind, even if it's just the movement that they need for wind, these systems won't be maintained and you no longer have that integrity. You don't have that protection. And then finally, the conditions of acceptance in ANSI UL 2079 provide criteria for an assembly rating with an optional L rating and or W rating, the water leakage, or excuse me, for water. The L rating determines the amount of air leakage in cubic feet per minute, linear foot of joint opening through the joint system, again at the 400-degree air temperature at an air pressure differential of 0.30 inch WC. And then the L ratings are intended to assist the AHJs and others in determining the suitability of joint systems for the protection of openings in floors and smoke barriers for the purpose of restricting the movement of smoke in accordance with NFPA 101. So again, talk about the L rating there. And then just some examples of some dynamic and static systems. Here's a dynamic. You'd know that by the D, the FFD 2000. This is a dynamic system. Here's an S, so static. Most of the time, we'll generally see the dynamics. We need the movement, but some, we got concrete to concrete. You don't need that movement sometimes, so you can have an S. But typically, you're going to see a D dynamic listing. Just some examples of different joint systems. And then for curtain wall assemblies, they have the specific section, the void created at the intersection of a floor ceiling assembly and an exterior curtain wall assembly have to be protected in accordance with 715.4. So about the installed, of course, in accordance with the manufacturer's installation listing, but also the manufacturer's listing. The manufacturer's installation requirements, and that's for its entire length, of course. So it doesn't impair the ability to accommodate expected building movements and to also resist the passage of fire and hot gases. This exception does not apply to the charging section for SFM regulated occupancies, but this is talking, so the charging section is saying that the fire resistant joint system shall be tested in accordance with the requirements of either ASTME 1966 or UL 2079, and that the non-symmetrical wall joint system shall be tested with both faces exposed to the furnace, and the assigned fire resistance rating shall be the shortest duration obtained from the two tests. When evidence is furnished to show that the wall was tested with the least fire resistant side exposed to the furnace, Subject to acceptance of the building official, the wall need not be subjected to test from the opposite side, because if the side that has the least protection passed the test in the furnace with the fire, then it's to assume the side that has the greater protection is going to be fine. And then the exception, again, this exception doesn't apply to the occupancies that we look at. So it does have to be tested, and basically when does the weakest side fail? And did it fail at a point that means it passed the test or it did not? That's basically what that's talking about. And then the exterior curtain wall floor intersection, the 715.4 that we just mentioned earlier, where the fire resistance rated floor or floor ceiling assemblies are required, voids created at the intersection of the exterior curtain wall assemblies and such floor assemblies shall be sealed with an approved material or system to prevent the interior spread of fire. Such system shall be securely installed and tested in accordance with ASTM 2307. So make sure what you're using is obviously meeting the right ASTM standard that needs to, and provides an F rating for a time period of at least equal to the fire resistance rating or floor assembly that it's at. And then height and fire resistance requirements for curtain wall spandrels have to comply with 70585. Exception for this is when voids are created at the intersection of the exterior curtain wall assembly and such floor assemblies where the vision glass extends to the finished floor level, they shall be permitted to be sealed with an approved material to prevent the interior spread of fire. Such material shall be securely installed and capable of preventing the passage of hot flame and hot gases sufficient to ignite cotton waste where subjected to the ASTM 119 time temp under the same pressure differential. But remember, some of these are still going to need an L rating for us. This is just a visual for you. And then for the exterior, so the voids create the exterior curtain wall assemblies and non-fire resistance rated floor or floor ceiling assemblies shall be sealed with an approved material or system to retard the interior spread of fire and hot gases between stories. So that's when you don't have rated assembly. So again, something you're not going to see too much with what we look at. Sorry about that. And then voids created at the intersection of non-fire resistance rated exterior curtain wall assemblies and fire barriers shall be filled. So again, if you got something that's rated, you got to have that continuity there, whether it's a joint, a penetration, another assembly, whatever it is, you got to have that continuity, or you're going to have a space for smoke or flame to heat to go through. And then, of course, the approved material system shall be used for the whole length, and it can't dislodge, loosen, or otherwise impair its ability to accommodate the fire and hot gases. And then a spandrel wall, which is like an opaque glass wall, for height and fire resistance requirements for curtain wall spandrels that shall comply with 70585. And 70585 doesn't require fire resistance rated spandrel, where 70585 does not require a fire resistance rated spandrel wall. The requirements of 715.4 shall apply to the intersection between the spandrel wall and the floor. So, example for you, this one does actually have an L rating too, so it's good. It's got the F, the T, and the L. Just an example, not a must use, but is still helpful. And then fire resistant joint systems and smoke barriers. Fire resistant joint systems and smoke barriers and joints at the intersection of horizontal smoke barrier and an exterior curtain wall shall be tested in accordance with the requirements of UL 2079 for air leakage. The L rating of the joint system shall not exceed 5 CFM per linear foot of joint at 0.30 inch of water for both the ambient temperature and elevated temperature test. So of course, you see some similarities with the L rating requirements for when you need it at the different types of assemblies, but you gotta, you're going, floor to floor. For example, your heat, where's it going to be? It's going to be up at that upper level, right? So the testing, the limitations here are a little bit different. So just make sure you've got the right L rating for one, that you have the L rating, and then two, you've got the L rating that meets the specific criteria for where you're penetrating the wall, floor, curtain wall, etc. And then just an example. This is what you want to prevent. And then for opening protectives, this is the part where we're just going to kind of cut off and part way through. So we're into 716, and 716, like I mentioned, is very lengthy. I would just do a part of it here and then pick up in portion 3 with more details on doors. So, but again, this section for the openings, all well, you got doors, windows, etc. And at 716, a lot of people go right to the table, which is great, but you can't enforce the, say you see a comment, this, on one of the plans that this doesn't comply with 716, blah, blah, blah. When we do that, we can't write can't cite the table by itself, but where does the information in the table come from? It comes from the charging section. So if you're looking at the table but need a little bit more information, always just go to the matching charging section for what you're looking at. You're looking at a door and a firewall, you're looking at a fire barrier, smoke barrier, you're looking at glazing that's tested as a wall, looking at glazing that's just tested for glazing, etc. Go look at some of the language there. So starting off with the general, of course, is opening protectives required by other sections of this code shall comply with the provisions of this section and shall be installed in accordance with NFPA 80. So again, just like with the assemblies, the other portions of the code will tell you when you need them. And then 7 tells you the how do you do this? And then NFPA 80, for those who aren't familiar, that's the standard for fire doors and other opening protectives. So if the code requires these openings, and these openings have to be protected, they have to comply with this section, and they have to be installed in accordance with NFPA 80. So always make sure to look at both. And alternative methods for determining fire protection ratings. The application of any of the alternative methods listed in this section shall be based on fire exposure and acceptance criteria specified in NFPA 252, 257, and UL 9, 10B, or 10C. The required fire resistance of an opening protective shall be permitted to be established by any of the following methods or procedures. So you've got a material that doesn't you don't have a listing for it, and you want to do an alternate. The alternate has to be based off of the acceptance criteria listed here. And then again, the opening protectives shall be permitted to be established by any of these following methods or procedures. So you can give us designs documented in approved sources, the calculations that are performed in an approved manner, and an engineering analysis based on comparison of opening protective designs having the fire protection ratings as determined by the test procedures. Again, just reiterates it here, set forth in NFPA 252 and 257, UL 9, 10B, or 10C, and then other alternative protection methods as allowed in 10411. So just, again, if you're using an alternate, you don't have a listed, it's got to look at this section, for the criteria that have to be met to provide that alternate to us. All right. So for glazing, the glazing used in fire door assemblies and fire window assemblies shall comply with this section in addition to the requirements of 716(2) and 3. So this, you'll have the general information, then you're going to have some specific information. So still part of this section, the safety glazing, fire protection rated glazing, and fire resistance rated glazing. If you remember from the first time, those two different things. One's tested as, could be tested as a wall, one's just tested as the opening. But fire protection rated glazing and fire resistance rated glazing installed in fire door assemblies shall comply with the safety glazing requirements of Chapter 24 or applicable. So you're not, usually when you're in the code, you're not just in one spot, right? So you've also got to look at what the requirements of 24 say have to be in place for safety glazing. And then you'll go pretty much right to 2406. So not only do the glass or glazed panels need to be fire resistance rated, but the glass also must pass the test for the CFR 16 if it's installed in locations subject to human impact load. So looking at all kinds of things with these, what's the frame, what's the glazing, is it tested as a wall, is it tested as regular opening, and does it meet all the requirements for safety glazing in chapter 24? So those little tags in the corner of the window have a lot of information. And just to refresh your memory, or if you weren't there for the first one, you heard me a little bit of change with how I was saying fire protection rating and fire resistance rating. It's because they're two different things. And these are the definitions are in chapter 2. So fire rated glazing, what we're talking about as a whole, that's defined as glazing with either a fire protection rating or a fire resistance rating. And then the fire protection rating are opening protectives tested at NFPA 257 or UL9 windows, or NFPA 252 or UL10B or 10C doors. Fire protection rating, they're tested as those openings or doors. But then fire resistance rating, that's for building elements. So if that glazing was tested, went through the same test as the wall, the ASTME 119 wall test, if the glazing's tested as a wall, then that's considered fire resistance rating, rated protected glazing. If it's tested through the fire protection rating, then it's tested as an opening protective as opposed to a building element. And that helps when you've got some size limitations for glazing, and so those limitations in some assemblies go away if that glazing is tested as a wall. But if it's tested as an opening, you'll still have some limitations. So it can help if, it's expensive when it's tested as a wall, but it can help when you have an area where you've got a want, or the owner has a want of a large area of glazing. So please, this is a really important slide. Keep these in mind. Look at how your glazing is tested, and that will help you with the code it's right there too, but where you can use what. So, and then for the markings, we'll move on to markings. The fire rated glazing assembly shall be marked in accordance with table 716, 1, 2, and 3. The fire rated glazing identification. For fire rated glazing, the label shall bear the identification required in table 716, 1 and 2. D indicates that the glazing is permitted to be used in fire door assemblies, and that the glazing meets the fire protection requirements of NFPA 252, UL10B, or 10C. So when you're looking at the table, this is what I mean. If you see stuff in the table, like, I don't know, what do those little letters even mean? Go to the charging sections and you'll see them explained. H shall include that the glazing meets the hose stream requirements of NFPA 252 or UL10B or 10C. So not all of them have the hose stream. Some they'll have the test requirements with the flame, and then some will also include the hose stream test where they hit it with the hose. T shall indicate that the glazing meets the temperature requirements of 716.2231. And then the placeholder XXX represents the fire rating period in minutes. So how many minutes was it tested at? So the marking is very important, and that'll tell you how your glazing was tested, and then obviously the criteria that it meets. The fire protection rated glazing identification. So let me back up. Yeah, the fire rated glazing identification and the fire protection rated glazing identification. So again, the two different, how was it tested? Was it tested as a wall or tested as an opening? For fire protection rated glazing, the label shall bear the following identification required in table 716, 1 and 3. So OH and then XXX. The O and the H indicates that the glazing meets both the fire protection and hose stream requirements of NFPA 257 or UL9, and is permitted to be used in fire window openings. And then the placeholder XXX again represents the fire rating period in minutes. And again, fire resistance rated glazing. For fire resistance rated glazing, the label shall bear the identification required in 7036 and 716.1.1. So the bug, sometimes people call it the bugs. You got to look at this on the actual glazing. Just a little bit of a visual for you for the tables. So you'll see this is 716.1.1. This table is the marking fire rated glazing assemblies. And the tables have changed through the years. So if you're looking at different editions of the code, obviously stay in the edition that your project is in. But the later ones have really helped, the tables have really helped differentiate between like what is what and what do you need to see what was my glazing tested as. So if you're, again, tested per ASTME 119, UL 263 tested as a wall, you'll see the marking W, and it meets wall assembly criteria. And if it has FC, then that means it meets the floor ceiling criteria. And there's a footnote in there to go see when you have the floor ceiling. Go also see 2409.1. So right there, those will tell you, right, remember your ASTME 119, UL 263 are the testing criteria for when it's an assembly, the building element, tested as a wall. And then the others, if it's NFPA 257 or UL 9, and it says OH, again, that meets the fire window assembly criteria, including the hose stream. So it's the opening in the hose. And then the next one, NFPA 252 or UL 10B, 10C, you've got DH and T, D's for door. H, it also has the hose stream test as part of its test. And then T, what's the temporized criteria? It had 450 degree temporized criteria for 30 minutes. And again, the XXS is the time. Is it 20 minutes? Is it 3/4 hour? What is it? That will be where the XXX is. And then table 716.1, number 2, is the opening fire protection assemblies for ratings and markings. So you're going on the left, you're looking, what type of assembly do you have? Do you have a firewall? Do you have a fire barrier that has to be rated more than an hour? Do you have a shaft enclosure for shafts, interior exit stairways, and interior exit ramps? Horizontal exits in firewalls. So yeah, horizontal, so very specific, right? Because a horizontal exit's fire barrier, right? So if you go fire barrier and you look up to that first one, it says fire barrier greater than an hour, I'm going to use that. Well, hold on a minute, this is specific. You got fire barrier, that a horizontal exit, that's a fire barrier, but then a horizontal exit and a firewall. Just make sure you're looking at the right type of assembly. And then you got other fire barriers having a required fire resistance rating of 1 hour. And enclosures for shafts, exit access stairways, exit access ramps, interior exit stairways, and interior exit ramps, and exit passageway walls. So all those types follow this one. And then other fire barriers. If you got a fire barrier that's not one of those listed above, follow this one. And then it goes to fire partitions and corridor walls, and then other types of fire partitions. So these tables are hugely helpful. And then of course it goes through what's the rating that's required for so figure out what type of assembly you have, and then what rating is required for that. And then what do you need for the minimum fire door and fire shutter assembly rating? What's the door vision panel size? What are the limitations for that panel size based on the type of assembly that door is in? And then what markings do you need to see? The D, the H, W, what's the time? What do you need to see on there? And then there for the side light and transoms, and then the fire rated glazing markings with the side light and transom. And then the rest of the table. And then a bunch of visuals to help you. So there's one that shows with the side light and what it looks like after you follow through the table, just some visuals to help out. Then you got table 716.1.3, and that's for fire window assemblies fire window assembly fire protection rating. So go through the same thing. What type of wall assembly do you have? Is it interior? Is it exterior? What's the rating that is required? And then what's the minimum fire window assembly? And then what's the fire rated glazing marking that you need? Again, how is it tested per wall, as a wall or as opening? Don't forget your footnotes. And all right, glazing, fire rated glazing that exceeds code requirements. This is telling you if it exceeds the code, it can be used. Why that had to be put in there, I don't know. But if it exceeds code, fine, use it. Fire resistance rated glazing tested as part of a fire resistance rated wall or floor ceiling assembly in accordance with ASTME 119 or UL 263 and labeled, tested and labeled in accordance with 7036 shall not otherwise be required to comply with this section where used as part of the wall or floor ceiling assembly. So again, when you have that's the glazing that's tested as a wall, it really opens up a lot of doors for you, no pun intended there. Glazing in fire door and window assemblies, fire resistance rated glazing shall be permitted in fire door and fire window assemblies where tested and installed in accordance with their listing and where in compliance with the requirements of this section. Fire door assemblies required by other sections of this code. Again, the other parts of the code tell you you're going to need it. This one tells you how. That if you have these, they shall comply with the provisions of this section. Fire door frames with transom lights, side lights, or both shall be permitted in accordance with 716.254. If it was tested and listed as it can be used. Testing requirements. An approved fire door and fire shutter assemblies shall be constructed of any material or assembly of component materials that conforms to the test requirements of 716.211 to 214 and the fire protection rating indicated in 716.2 in that table. And then exceptions to this labeled protective assemblies that conform to the requirements of this section or UL 10A, UL 14B, and UL 14C for tin-clad fire door assemblies. And then exception 2, floor fire door assemblies in accordance with 712.1.13.1. If you've got a fire door assembly in your floor, there's a whole, they have their own specific requirements because again, of course, it's going to be tested differently, right? A door that you're walking through, room to room, as opposed to not that you're going to be going through the door assembly and ceiling, but like a hatch or something, that heat's going to be up there, right? So that those floor fire door assemblies have their own requirements because you're going to have heat. The heat's going right up to those, so they have more requirements for that. So yes, I'm sorry, we did switch to fire doors. We moved from glazing to fire doors. And then side hinged or pivoted swinging doors, fire door assemblies with side hinged and pivoted swinging doors shall be tested in accordance with NFPA 252 or UL 10C. And then for tests conducted in accordance with NFPA 252, the fire test shall be conducted using the positive pressure method specified in that standard. So again, if you've got a fire door assembly and it's in a it's a side hinged or pivoted swinging door, it has to meet this criteria. And then in other type of assemblies, the fire door assemblies with other types of doors, including swinging elevator doors, horizontal sliding fire doors, rolling steel fire doors, fire shutters, bottom and side hinge chute intake doors, and top hinged chute discharge doors shall be tested in accordance with NFPA 252 or UL 10B. And then for tests conducted in accordance with 252, the neutral pressure plane in the furnace shall be maintained as nearly equal to the atmospheric pressure as possible at the top of the door as specified in the standard. You'll see this in your testing criteria that comes with your product. Just make sure it's there properly for where you are using it. And then when you have glazing in your fire door assemblies and glazing in the transom lights and side lights in the corridors and smoke barriers. So again, with this section, it lines up with the tables, but you want more information, look at these sections. What type of door do you have? Does it have transom and side light? Where is the door? In this section, we're talking about the doors, this type of door that has transom and side lights that are in corridors and smoke barriers. Then the glazing material in any other part of the door assembly, including transom lights and side lights, shall be tested in accordance with NFPA 257 or UL 9, including the hose stream test in accordance with 716.311. So when you have these types of doors in your corridors or smoke barriers, they have to also have the hose stream test included with their tests. So even though you have a 20-minute door, your side light and your transom would have to be 45 minutes and also include the hose stream portion of the test. And markings, you'll need to see the different markings on the different pieces. So the marking on the side light is going to look different than the marking of the vision panel in the door, and then the door is going to have its own marking. All of these have to be looked at, as well as the frame, of course. So when you have a smoke and draft control door, the fire door assemblies that serve as smoke and draft control assemblies shall be tested in accordance with UL 1784. So if you've got an area that requires a smoke and draft type door, there are additional testing requirements that need to be in place. And that's UL 1784, which also means you're going to have other markings on that door. And then the performance requirements, fire door assembly shall be installed in the assembly specified in 716.1.2 and shall comply with the fire protection rating specified, of course. And then back door assemblies and corridors and smoke barriers. Fire door assemblies required to have a minimum fire protection rating of 20 minutes. We're located in corridor walls or smoke barrier walls that have a fire resistance rating in accordance with 716.1.2 shall be tested in accordance with NFPA 252 or UL 10C without the hose stream test. And then the viewport, there are exceptions for the viewport. If it requires the viewport or viewports that require a hole not larger than 1 inch in diameter through the door, have not less than 0.25 inch thick glass disc, and the holder is of a metal that will not melt out where it's subject to temperatures of 1700 degrees. So if you have a viewport, make sure it meets these if it's not part of the other test. Then exception 2, corridor door assemblies and occupancies of group I2 and 2.1 in fully sprinklered buildings shall be in accordance with 40731, because 40731 will have more specific criteria when you're in the I2. And we'll skip the second one. You're not doing theaters, horizontal sliding doors and smoke barriers that comply with 4086 and 4088. Oh, that's an I3. Sorry about that. 5 is about an I3, and then for 6, talking about safety room doors, that's not for us. And then smoke and draft control doors. The air leakage rate of the door assembly shall not exceed 3 cubic feet per minute per square foot of door opening at 10 inches of water for both the ambient temperature and elevated temp test. And then louvers are prohibited, of course. I don't know why we have to write that. Holes in your door kind of defeats the purpose. You got here you can see the tag. You've got a 3-hour, or I have to read the whole tag to you, but it's 3-hour. It does have an S rating, and it does conform to all. It has the temporize, and it also conforms to the 10B, 10C, etc. This is like your be-all door here. 716.2.2, don't even worry about it. We don't have half-hour fire partitions in California. We only have an hour, or not only, but we have an hour. Then you get into 223, which is about the doors that are in interior exit stairways and interior exit ramps and exit passageways. Again, make sure you look at the section that goes with what you're looking at. Is your door in the corridor? Is it in the smoke barrier? Is it in the stair? Is it in the ramp? So fire door assemblies and interior exit stairways and ramps and exit passageways shall have a maximum transmitted temperature rise of not more than 450 degrees above ambient at the end of 30 minutes of a standard fire test. So if you have the doors in the interior exit stairways, they do need the temp rise, but then the exception, if you don't need that, if the whole building is fully sprinklered. That's why you don't see that too much anymore. We still do have some of our old buildings, the pre-March 472 1As that may not be fully sprinklered, so they'll still need these doors, but the others should be fully sprinklered and you shouldn't need the temporize in those doors. And then the glazing in the doors, again, you're still in the interior exit stairway doors and the exit passageway doors. The glazing in those doors that exceed 100 square inches is not permitted. Fire resistance rated glazing in excess of 100 square inches shall be permitted in fire doors. Listed fire resistance rated glazing in a fire door shall have a max transmitted temperature rise in accordance with 716.223, where the doors tested in accordance with 252, 10B, or 10C. So the your glazing in an exit enclosure door has to be tested in accordance with the temporized requirements when it's when that glazing is greater than 100 square inches. So again, watch that, because we just said you don't need that temporized, right? But if you've got glazing that exceeds the 100 square inches, you will need this test. But those are pretty big windows. We typically don't see those, but if you have them, now you are back to needing the temporized. Just a visual for you. So it limits the glazing to 100 square inches in the exit enclosure doors. If it exceeds that, you've got additional testing that has to occur. And then fire doors installed within a fire door assembly shall meet the fire rating indicated in 716.1.2. What does it need to be rated as? And the frames have to meet the same requirements, rating requirements. Fire rated glazing conforming to the opening protection requirements in 716.2.1 shall be permitted, of course, in the doors. And then there are size limitations. Make sure you're looking at again, where the door is, what kind of assembly it's in, and can glazing even be in that door? And if it can, what are the size limitations? And what does NFPA 80 say about those size limitations? Here's what it says, in case you were wondering. So the 80 permits the fire protection rated glazing and fire doors with a fire protection rating of up to 3 hours. So up to the hour and a half doors, the allowable area is a function of the glazed area tested. And then 1 hour and an hour and a half doors that require temporized ratings are limited to 100 square inches or less. And then while 80 allows a view panel of 100 square inches or less in the 3 hour door, table 716 doesn't. So remember, code trumps that then. We're more stringent. So if you've got that exceeds the 100, you have to have that additional test, even though NFPA 80 allows it, because we're more stringent. But for the other doors, it pretty much matches, the criteria matches. Fire resistance rated glazing in door assemblies and fire walls and fire barriers. Now you're looking at fire walls and fire barriers greater than 1 hour. Those, when it's tested per the wall, the STMA 119, and then 250, NFPA 252, UL 10B and C shall be permitted in fire door assemblies located in the firewalls and in the fire barriers in accordance with 716.5 to the maximum size that it was tested. What size was it tested at? It can be in there to that maximum size tested, and of course installed in accordance with their listing. So fire, again, I have these underlines, fire resistance rated glazing, not fire protection rated, or excuse me, fire protection glazing. So fire resistance rated glazing shall be permitted in firewalls and fire barrier walls to the maximum size tested, and as allowed in 716.1.2 to 716.1.2 say you can have it, okay, you can. And then what was it tested at? That's how much you can have in it if it was tested as the wall. And the glazing, if used in a fire door view panel, must be tested to 2 standards, both ASTME 119, UL 263, and NFPA 252 or UL 10. If you're going to say this glazing is going to act like a wall, it's going to meet a lot of criteria. And then again, where this is fire resistance rated, tested as a wall, fire protection rated, indoor assemblies and firewalls and fire barriers. So again, it matters how it's tested, but you're still in firewalls, fire barriers, greater than an hour, then it meets this criteria here. And so fire protection rated glazing shall not be allowed in firewalls or fire barriers greater than 1 hour. So if you've got glazing in your firewalls or barriers, that those are required to be rated more than an hour, you can't have these except for the 100 square inch or less view panels in the fire doors or horizontal exit and fire barriers. And then that view panel is important because it allows, that allowance recognizes the benefit of visual observance in an emergency situation. Do you want to go through that door? Is there smoke on the other side? And then horizontal exits, fire protection rated glazing shall be permitted as vision panels in self-closing swinging fire door assemblies serving as horizontal exits in firewalls where limited to 100 square inches. So only self-closing swinging fire doors in firewalls that serve as a horizontal exit are allowed the limited size view panel. Only these can have that. And then for fire barriers, fire protection rated glazing shall be permitted in fire doors having a 1.5 hour fire protection rating intended for installation in fire barriers we're limited to 100 square inches. So for this one, only fire barrier doors required to be an hour and a half fire rated are allowed to have the limited area view panel. But some fire barriers have to be 3 or 4 hour. So doors with the 3 hour, again, would not be allowed to have the view panels. And then for when you got them in the elevators, so stairway or ramps, then approved fire protection rated glazing used in fire door assemblies in the elevator, stairways, and ramp enclosures shall be so located as to furnish clear vision of the passageway or approach to the elevator, stairway, or ramp. Again, the purpose of the view panel in exit doors is to permit observation by occupants who may be on the other side of the door before opening it. And then the size limitations still apply. Glazing in door assemblies and corridors and smoke barriers. So we were talking about the doors before, we're talking about the glazing in the doors. In a 20-minute fire door assembly, and I'm sorry, back up a little bit, and doors, how are they tested? As the openings or as walls, like the wand door, for example. But anyway, glazing in door assemblies and corridors and smoke barriers. In a 20-minute fire door assembly, the glazing material in the door itself shall have a minimum fire protection rated glazing of 20 minutes and shall be exempt from the hose stream test. When they have the transom lights, you got some requirements here for when they have the transom, and don't forget the frames, well, in all of them. And you've got the section thrown in here for energy storage system separation. Fire protection rated glazing shall not be permitted in fire door frames with transom lights and side lights and fire barriers that are required by 1206 of the fire code. So if you have a fire barrier that's required around the energy storage system, you can't use the same allowances for the other fire barriers. This is specific. You can't have these openings like that in the there's a glazing in the barriers that are specifically for the energy storage systems. Again, this is a visual for when you have the 3/4 hour fire protection rated or less. This is for when it's greater than 3/4. And this slide I put at the end, should have had at the beginning, but if you participated in this today, then you get an hour and a half of AIA credit for attending this, and you should see it within 10 days of this presentation. And I do that with about 2 minutes to spare. So thank you very much. I know a lot of information, and this is something that when we go over it in-house here, this takes much longer. We go to it in much detail, but in this presentation, I know some people have a lot of experience and some people are newer, so it's a refresher for some, but always good to go over. And if it's new for you, please go over this again. But remember, where is the opening? Where's the penetration? Where's the joint system? What type of assembly is it in? What's the rating? It's going to need to match. And then what are the allowances for each of those, and how, like for these openings, we kept saying multiple times, how is it tested? Are those openings, those walls, those doors, what are they tested as? Tested as a wall or an opening? And then go with the specific criteria for those. So a lot of information, short amount of time. I hope you're still awake too, but anyone have any questions at the moment?
Thank you, Nanci. We do have some questions that were typed into the go-to question box. So I'll go ahead and read them off to you if you want to go ahead and maybe provide an answer. I'll go ahead and start with the first question. It reads, what exactly does a positive pressure differential mean?
That's a lot to go into, but what's the pressure on one side versus the other? So there's a lot that comes into play with that. So in a fire condition, you're going to have certain pressures built up because of the fire. And this is part of the test criteria of basically is whatever you're looking at, whether it's whatever protection you're looking at, does it withhold with the pressures that are expected during fire conditions. So there's way more there. That would be way long to answer sufficiently, but it's basically, is this assembly, is this protection going to be maintained in a fire condition with the pressures that occur because of fire conditions?
Great, thank you. Thank you for that. We have a couple more questions. If I can, I'll go ahead and read the next one. It says, if I have an electrical box installed on a concrete floor, is this exempt from the T and L rating?
I have to go back to the whole, might have to go back to the section and go through all that, because those are the ones that have the exceptions. But if you have it through the floor, it's going to have a specific testing criteria for it because it's in the horizontal assembly. And then I would have to go back and read the sections that say, does it have to have it or does it not? The T of the F it's going to need an F rating. And maybe, well, let's see if the question, you mean embedded? The part of it's embedded within the concrete, and that might be what that question means, as opposed to
Yeah, and the question does read, it says, if I have an electrical floor box installed on concrete floor, is this exempt from the T and L rating? So it sounds like the electrical box is within that concrete.
Okay, so probably better to. I always tell everyone, whenever even if you think you know it, always look it up, because it's better to. You don't think you can memorize it all. I'd feel better looking that up for the specifics. So right. Membrane or through, that's, obviously that comes into play with that. But let me see if let me just go through one of these here. I got to look through the whole thing because I don't want to give the wrong information. But you typically are going to need the F rating for that, which got to be tested with it. Or I think that's part of it too, was it tested as part of the assembly, or is it tested and listed by itself? And how you look at that, but typically the F is going to be needed.
Yeah, I'll take this opportunity to remind everyone that if you have a specific question, there may be that we answered the question but didn't really get to the answer you were looking for, feel free to send us an email over to regsunit@hci.ca.gov. Again, that applies for anything you have questions about, whether it's a specific issue at a specific project or anything having to do with this presentation. So Nanci, if you don't mind, I'll go ahead and go to the next question. The next question reads, when is the bottom of wall joint required to be protected? There are very limited UL assemblies for this condition.
Yeah, that's something we talk about that in-house a lot. Is like, yes, it is a thing, and yes, there are listings for that. But if you're in a space where, well, hopefully you're not in a space where there's fire, but and it's to the point where it's now going through the bottom of the wall, you won't be seeing it. You'll be on the floor. But anyhow, it is. I don't want to downplay that. I guess it is important. But what's the intent, right? You're preventing smoke and heat and flames and gases. You're preventing it from going from one space to another. Those are going to be higher, right? They're going to be going up towards the ceiling level, and aren't typically a concern in a fully sprinklered building at the bottom of wall assembly. But say you've got a gap that's and this is not what the code says, right? The code's going to say you need it, but it's usually pretty tight to the floor ceiling assembly below, plus putting the floor covering on top of it. If you have a big honking gap at the bottom of there, you're probably not going to, right? It's not how you do your construction, or shouldn't be. It is important. It is there. So I hate to say don't do it because it's there, but use some reasonable judgment. Again, what's the intent of it? It's to prevent the smoke and flame from going back and forth, and that's going to be traveling higher up. Heat rises, it's going to be going higher up. So if it's the point that now you've reached bank down or your room's fully involved, and yeah, now it will spread. But it shouldn't get to that point in the fully sprinkled building, and two, it shouldn't have that much of a gap at the bottom. But if there is a gap and it's not, maybe the wall was off for whatever reason where it met the floor, then you may need one there just to close that gap. But typically you're pretty tight to the floor assembly. You typically don't need it. I just use caution with that because the legalese side of it, right? code says you need it, but use some reasonable judgment with that. It's not something that is typically a problem.
All right, thank you for that. We do have another question. The question reads, for code section 7.14.5.1.2, exception 2, would above a T-bar ceiling meet the quote, within a concealed space of a horizontal assembly, end quote, requirement?
7.14.5.1.2 is the through penetration fire stop systems. And number 2 for tub drains, shower drains. So can you read that again, please?
Yeah, the question reads, for code section 7.14.5.1.2, exception 2, would above a T-bar ceiling meet the quote, within a concealed space of a horizontal assembly, end quote, requirement?
Oh, so above the drop down ceiling is not a horizontal assembly by itself. The floor ceiling assembly above it is the assembly. And then if the ceiling's required to be rated, and that becomes a membrane penetration, and protection would be needed at the membrane penetration. But look at what do you have? If it's a rated ceiling, floor assembly, ceiling, roof assembly, rated ceiling floor assembly is going to be higher above the drop down ceiling. A rated ceiling roof assembly, again, that ceiling portion is going to be part of that rated membrane, and that would have to be protected there. But if you're talking like a 1A, type 1A building, and you got a drop down ceiling tile and you got penetration going through that drop down, then you've got your void space, your concealed space, and then you have your horizontal assembly above that, which is your floor ceiling assembly to the next floor up. So there again, without having the specifics, it sounds like it's just a typical drop down. With the horizontal assembly is actually above that. But if you're like in a 5A and it's a ceiling roof assembly, then your ceiling portion is a membrane portion of the assembly and would have to be protected above and below that, but not through the roof. But anyhow, hopefully that helps that individual.
Okay, great, thank you. Next question reads, where can you find what walls and how long they should be rated? Example, IT rooms, electrical rooms, stairwells, etc. I believe chapter 6 only talks about party walls, perimeter walls, bearing and non-load bearing walls.
Yes, so all over the place. So you're going to have different sections that say, like in 407, for example, you're going to have a section that says when you have a corridor in an I2, it needs to be rated, and it's per chapter 7. And then you go in there and you look at corridor wall, it'll say that wall needs to be a 1 hour. In an IT room, you're going to have some requirements in the electrical code, and we match where we can. So IT might say, here's where you need it here. You need a rated assembly here. And then the building code will tell you how do you build it. So, and AO 1206, CFC 1206, like we mentioned with energy storage systems, 12 is going to have some requirements where you have, if you have those rooms with energy storage systems in it, then those will be required to be rated. So you're going to have, that's going to tell you it needs to be rated, and at what in combination with 509 and 5. So in chapter 5, you'll see a lot like if you're talking about different, if you've got your dining and your kitchen in your I2, so you've got, that's considered an A, and we'll need a 2 unless there's a commercial oven. It might be an F1, but either way, it'll tell you the requirements in 5084, what rating needs to be between these different uses. But that goes into a whole other class too, because some of them could be accessory and not need to be separated. But if they're required to be separated, then you'll see the hourly rating in that section. So it's kind of, there are a lot of sections, a lot of different areas of where it says what rating you have to have. And then like stair enclosures, you're going into chapter 7, and as well as 6 is, so you've got, you're all over the place. It's going to be all different parts of the code and different codes. What does the mechanical code say you need something? Does fire code say you need it? Does electrical code say you need it? And then different sections in the building code.
Okay, that's a lot of information. We hope that that answer helps. If not, send us an email. We have a couple of more questions, and then we'll call it a day. We are 10 minutes past our designated time, so we're going over the Q&A portion of it now. So if you'd like to, you're more than welcome to stick around for these questions, and we hope that it's helping you out. The next question, Nancy, reads, is there any assemblies for existing fire-rated systems versus new construction systems, especially if there is no record of what type of assembly was originally applied?
Yeah, that's always fun, right? So a couple of things with that. There are a couple of resources that can be looked at. Let me see if I can find the name real quick. I'll talk a little bit first, and then let me see if I can find it. But there's Harmathy's law or Harmathy's rule, I think it is. That's something that can be used where it's what do you have? You got this thickness of plaster, lath and plaster. It's this thickness, and what should that be equivalent to? It should be 1 hour, whatever. It'll give you like resources to kind of measure that. You look at what you have, look in this resource, see if it meets those dimensions, and it'll give you an approximate rating that it may meet. ICC has another one. I'll try to look up the name here if I remember what presentation I put it in. That they have a resource where you can look at what they call archaic construction, which is kind of funny because what they consider archaic is pre-1950. I'm like, that's not nice. That's not archaic. But anyhow, so they have a resource for what they call archaic construction and some equivalencies that you can look at. You can look at 721, the back of chapter 7, sometimes forgot about. Look at those tables and see if some of your conditions match similarly to that. And some of it just goes back to historical knowledge where we can look up some, it should be the design professional looking that up too, but go out, boots on the ground, and look what you have, what's the thickness, what materials do you have, and look at a couple of these resources to help guide you to an estimate of what that rating might be. And then along that topic, we're looking at, some facilities you're going to always deal with that, right? You have an older portion that is, you got a plaster wall, and then you've got a new addition on the other side. That wall's not going anywhere. So throughout the life of these buildings, having remodel projects and other projects going on, you're going to be constantly running into, okay, what do we do with this? There's not a listed approved assembly for this. What do we do? We're looking at facility specific pre-approved details. And so if you are in that type of facility where you're going to have these kind of projects over and over and over again with the same kind of walls, give us some details of what you have. We can look at those as pre-approved details, and we don't have the system set up completely yet, but we're obviously we can look at it, and then we'll set a system up more completely soon where you have this packet, so to speak, of these pre-approved details, so that every time you have a project, you don't have to recreate the wheel. You got the same wall you had 2 years ago, the same wall you had 10 years ago. And you have the similar type of penetration. So we'll be looking at that. So if you've got those, start to have the design professional, or if you are the design professional, create some details that are going to be common. You always will have some that are a little bit off that you might need an EJ for, or an alternate for. But if you've got common ones go ahead, create some of those details and let us review those. And we could potentially do pre-approved, where every time you got a project involving that wall with that type of penetration, we can say, yep, we've looked at it, this is the same, and move on. But as far as you don't have that and you're still just trying to find those two resources, again, Harmathy's rules, I think there's more to it. And I'm sorry, if I I don't remember what presentation I brought it up because that's how I look it up, is that the name of the presentation that I gave. I do have those two resources, but the one is from ICC, and it has something in its name that is revolving around archaic construction and how to do those comparisons with new to what they call the pre-1950 archaic. And then the Harmathy's rules or laws, whichever his are called, and that just gives some kind of like a guide. Like I said, is you go to that resource with the thickness of the type and thickness and size of material that you have, and it'll give a comparison of an estimated rating equivalency.
Great, thank you, Nancy. We have one last question that we'll go ahead and ask, and then we can wrap up the presentation. The question reads: if the exhaust duct 6-inch diameter penetrates through a 2-hour fire-rated assembly shaft and straight out to the exterior wall, does it need a damper installed? Is having a smaller area 6-inch diameter matter?
So you got a duct going through to a shaft, and at the point the duct penetrates the shaft, do you need a damper? Is that the question, basically?
Yeah, so the question is, the 6-inch diameter penetrates through a 2-hour fire-rated assembly shaft and straight out the exterior wall. Does it need a damper?
The point the duct goes to the shaft would need a damper unless it's otherwise prohibited, like if it's part of a smoke control system or it's exhausting hazardous materials or whatever, and there's an allowance to take that damper away, then yes, it would need a damper at the point it penetrates the shaft. But again, that's that's kind of, I don't like to do that without seeing plans, because sometimes there are some specifics that might change that. But in general, yes, it would need the damper at the point it penetrates the shaft. If it's you've got something that's in a room and goes straight up and out, and it doesn't go through any other floor levels, any other stories, that's going to depend on the type of construction there as well. So I go with it depends, right? It depends on the specifics, but generally speaking, yes, you've got a duct that's going through to a shaft. That point that duct penetrates the shaft would need a damper. But what's some other criteria? Is it going through other floors? Is it in a 5A where it's just going through? It's in one room going through the ceiling portion and then directly outside without traversing any other spaces. So there would be more that to give a more thorough answer, I would need just a little bit more, but that's the general answer.
Yeah, no, thank you for that. And that kind of brings me to the what we had mentioned earlier is if you have a specific question for a specific project, send it over to the regs unit at hci.ca.gov email, where we will be able to provide an answer for you, or maybe even have a phone conversation to help you out with what you're dealing with. And that email address is regsunit@hcai.ca.gov. Nanci, I believe that's the end of the questions for today. Is there anything else you'd like to add before we do closing comments?
I just want to thank everyone for attending, and I know it's really hard to sit through just code, and it can be kind of dry, but it's also really important. So I really appreciate you attending, and we will continue on with openings in a third presentation.
Right, and that brings me to my closing comments. If you're interested in participating in a third presentation at a later date, where we will continue to discuss the opening protectives portion, and we'll include information on duct and air transfer openings, feel free to pay attention and keep an eye out for that presentation that's going to be presented at a later date. And if you don't know, you're able to download past presentations, past webinars, such as CAN 2-11B, Accessibility in Healthcare Facilities, OSHPD 3 Clinics, Engineering Judgments, and much, much more by going to our website, www.hci.ca.gov. And feel free to sign yourself up for future presentation notifications by clicking onto and subscribing to our listserv function there on our website as well. So it's been a pleasure being with all of you today. Thank you for what you do and doing your part in providing access to safe, quality healthcare environments throughout the state of California. Thank you.